8-2, solving quadratic equations by factoring. This is actually my go-to method. I would always try factoring any quadratic first. And if they cannot be factored, because not all of them could be factored, then I would go with the quadratic formula, which we will get to in 8-5. So, using factoring, you need to factor it into two binomials, as it's shown here, x minus 9 times 5x plus 2. It has to equal to 0. Then once you have it factored, you use a zero product property, which states that for all real numbers a and b, if a, b equals 0, then either a equals 0 or b equals to 0. So now you would separate them into two separate equations and solve them simple one-step, two-step equations. Minus 9, add 9 to both sides, x equals 9 is one solution. Subtract 2, 5x equals negative 2, divide by 5, and x equals a negative 2 over 5. That would be your second solution. You can pause here, try your try-its. Here, solve each equation. Again, it's already factored for you. Separate them into two separate equations. 2x minus 1 equals to 0. X plus 3 equals to 0. Add 1. 2x equals a positive 1. Divide by 2. X equals 1/2. It's up to you if you want to leave it as a reduced fraction, or if it does terminate, you can put it as a terminating decimal. Subtract 3, and x equals a negative 3. So those would be your two solutions. When factoring, if something is factorable, that means you are able to solve it. You should either be getting two solutions or one solution. And then letter B, we have a 2x plus 3 equals 0. And a 3x minus 1 equals 0. Subtract 3. 2x equals a negative 3. Divide by 2. This one would be a terminating decimal if you decide to, or you can leave it as a negative 3/2. This one, you would have to leave it as a fraction because this would be a repeating decimal. So I would just, my preference, keeping them as reduced fractions. All right, now we're not always going to get so lucky, and our problems are not going to always be factored for us. You always do have to make sure that in order to solve something in standard form, in using factoring, it has to be written in standard form, and it must equal to 0. So they gave you a problem here. X squared plus 9x equals a negative 20. They added 20 to the other side. And if you are able to combine it with somebody, you could, but there was no other constant on the left side, so it goes at the end representing your C. And then you can factor it. These were the easy factorable ones. Remember that you're kind of undoing FOIL. So x squared, the first two numbers in each parentheses have to equal an x squared. X times x. The last numbers have to give you a 20 when you multiply them, and then when you combine the outer and the inner, they do have to give you a positive 9. So what two numbers when you multiply can give you a 20? You can make a list of all the different ways to give you a 20, but when you add them together, they have to give you a 9. Oops, that would be a 12. So it would be 4 and 5. The order does not matter, and they are both positive. Once you have it factored out into your two binomials, now is when you can go ahead and separate it. Minus 4, x equals a negative 4, minus 5, x equals a negative 4, and x equals a -5. You can pause and do your try-its. So letter A is already written in standard form correctly. ax squared plus bx plus c equals 0. So again, if I undo FOIL, my first two numbers have to equal x squared. So x times x. And then I have to find two numbers that when I multiply, give me a 64. And when I add them together, give me a positive 16 or 2 8s. Because they are identical, this would be an example of factoring that only has one solution. So since they're both the same, I just need to write one of them and solve it. -8 to both sides, and x would only equal a -8 for this problem. Letter B, x squared minus 12x equals 64. It's not in standard form. I would have to subtract 64 to the other side. There is nobody on this side that I can combine it with, so it represents my C, so I would put it at the end. So now I'm trying to find two numbers that when I multiply, give me a -64. So knowing that I need a negative when I multiply, I know I'm looking for one negative number and a positive number. And when I add them together, they're going to give me a -12, which means the bigger number needs to be negative. X squared, x times x, that would be a -16 and a +4. So x minus 16 equals to 0, x plus 4 equals to 0. Add 16 to both sides. X equals a +16 as one answer. And x equals -4 as your second answer. Example 3. A museum vault has an outer steel wall with a uniform width of x. The area of the museum vault's ceiling and the outer steel wall is 1,664 square feet. What is the width of the outer steel wall? First, you have to write an equation to represent the area of the vault, which is length times width. So x here and x here, that's two x's plus 20, an x and an x, 2x plus 40. And then I am going to use FOIL to multiply. 2x times 2x, 4x squared, 2x times 40, positive 80x, 20 times 2x, positive 40x, 20 times 40 is a positive 800, equals to 1,664. Combine your two like terms in the middle. 120x plus 800 equals 1,664. But now since I need to solve it by factoring, it does need to be written in standard form and it must equal to 0. So I have to subtract 1,664. Looking at the left, I do have a constant I can now combine it with. So a 4x squared plus 120x minus 864 equals to 0. Now before I even try, since I now have an A, before I even try to do slip and slide, remember step 1 in factoring is always check to see if you have a GCF, which a 4 can go into all three of these numbers. So I would divide everything by 4, and I now have x squared plus 30x minus 216 equals to 0. A lot better now to work with. Since the 4 on the outside of the parentheses does not have a variable, you do not need it anymore to solve your problem. It can just hang out there and you don't have to worry about it. So now I need to factor what's inside the parentheses. What two numbers, when I multiply, can give me a negative 216. I know I need a plus and a minus. And when I add together, gives me a positive 30. I know x squared is x times x. You can do your long little list of all the ways to multiply to get 216. 1 and 216, 2 and 108, 3 and 72, 4 and 54, and 6 and 36, which that would work to give me a positive 30 if 36 was a positive and 6 was negative. Once I have it factored out, x plus 36 equals to 0, x minus 6 equals to 0. Subtract 36. Now in a lot of these word problems, you are going to be getting two answers, but you're talking about the width of an outer steel wall, something that does exist, and if you measure that, you're never going to get a negative answer. So this negative answer, we can just rule it out. So the only possible answer for this would be a 6. So the width of the outer steel wall would end up being 6 feet, would be my answer for this problem, because a width cannot be negative. All right, we're just going to go straight to example 4. Using factored form to graph a quadratic function. All right, how can you use factoring to graph the function f of x equals x squared minus 2x minus 8? Factor it. What two numbers, when you multiply, can give you a negative 8, and when you add, gives you a negative 2. An x plus 2, an x minus 4 equals to 0. Separate them into two equations. X plus 2 equals 0, x minus 4 equals 0. This x would equal a negative 2, and this x would equal a 4. So when you graph it, your parabola, one point should be at negative 2, 0. Your other point should be 4, 0. These 2 points are reflections of each other. So that means your axis of symmetry is halfway between these two zeros. So you can add them together. A 4 added to a negative 2, or a negative 2 added to 4, doesn't matter, gives you a 2. 2 divided by 2 is a 1. So your axis of symmetry is a positive 1. And then to find your vertex, which is the point on that axis, you actually have two choices. You can plug it into your original problem, this one up here, 1 squared, 1, negative 2 times 1, negative 2, minus 8, 1 minus 2, negative 1, negative 1 minus 8 is negative 9. So your vertex is a 1, negative 9, that's why the point is here. So once you have your vertex, your two zeros, draw your parabola. Your other choice, if you were to plug in your axis of symmetry into where your x's are here, so this is what you had when you factored, you can plug in 1. So 1 plus 2 is 3, 1 minus 4 is a negative 3, 3 and negative 3 is a negative 9, and that's also the y of your vertex. So whichever way you prefer to do it. So a parabola is symmetrical, so the vertex is halfway between the two x-intercepts. All right, so here, We do have an A and there's no GCF here. So use factoring to graph. This is not one of the ones that I can just put X and X. I now have an A. So you can either do the table or you can do the slip and slide. My preference is slip and slide. There's no GCF, so I'm gonna go directly and slip 2 to -3. I get a -6. I am going to rewrite it without my A and my brand new C, which is a -6. Now I factor this one like the easy ones. X squared, now I can do X times X. What two numbers when I multiply gives me a -6, but when I add gives me a +5. A +6 and a -1. Don't forget to now slide the 2 back underneath those two numbers. 6 divided by 2 is evenly divisible, so X plus 3. 1 divided by 2 cannot, so if I'm left with a fraction, I need to make sure it's reduced, and then that denominator becomes a coefficient in front of the X. The numerator stays where it's at. That is now my factorization. I now separate them, make them equal to 0, and subtract 3. X equals a -3, that's one solution, plus 1, 2x equals to 1, so x equals 1/2. So, I'm gonna attempt to graph it over here. So 1, 2, 3, negative, and 1 here. So 1/2, 0.5. So my axis of symmetry is halfway between those 2 points. So to find your axis of symmetry, you get your 2 zeros, a -3, and I'm going to put the decimal, 0.5, and I need to divide that by 2. So -3 added to a 0.5 is a -2.5 divided by 2. My axis of symmetry is a -1.25, which would be, that's -1, a little bit closer to the 1. It's okay. It's not going to be perfect. Now to find my vertex that lies on this axis, I'm just going to put it back into the original problem. F of, I may not have enough space here. Two times -1.25 squared plus 5 times -1.25 minus 3. -1.25 squared times 2 is 3.125. Positive 5 times a -1.25 is -6.25. And when I add all of those numbers together, I get a -6.125. So my vertex is a -1.25 and a -6.125. So 1, 2, 3, 4, 5, 6, 7, be right about here. And then I can draw, it's not so pretty, but it's okay, your graph. It's supposed to be a little curve. That's example 4. Example 5, 6 examples total. How can you now write the factored form of the quadratic function related to a graph? So you have a graph, which means you can get your zeros from a graph. My zeros are, or x-intercepts, are a -5 and 1. And then you may want to use, you're going to have to use any point on your graph. Vertex is probably the easiest. So this right here, just how we have standard form, just how we had vertex form, this is now called factored form. A times x minus p. P is 1, 0, and x minus q. Q is your other 0, otherwise known as your x-intercepts. So, because they are both minus minus, you have to be extremely careful with the numbers that you are putting in to the parentheses. Since one of your zeros is a -5, you're putting in a negative where you already have a negative or a minus sign. That's why it turned to an x plus 5. And then you're putting a positive where you have a minus, so it stays as x minus 1. Just how we did in standard form, just how we did in vertex form, we need to find our a. So that's where the other point comes in handy. So they use the vertex, -2, -9. -9 is going to be your f of x, and your -2 is going to be your x value. So they replaced f of x with -9 equals a, what you're trying to find, x plus 5, so -2 plus 5, which is 3, and then x minus 1, so -2 again minus 1, which is a -3. 3 times -3 is a -9, so you end up having -9 equals a -9a. So when they divided -9 by itself, that's where they got that a is equals to 1. Since we always know 1 is always in front of a parentheses by itself, an x by itself, it's up to you if you want to put a 1 there representing the a, or you can just leave it by itself. When it's by itself, we automatically know that the a is a 1. So here's a try it question. What is the factored form of the function? So my final answer needs to look like this. F of x equals a times x minus p, parentheses, times x minus q. A, p, and q are represented by numbers. So first, find your two zeros. It touches the x at 3 and at 9. So you can start with f of x equals a x minus 3 times x minus 9. Now I need a point from this graph so I can replace it with my x and f of x. Again, if you want to use your vertex, you can. It might be the easiest point on there. So my vertex is a +6, and this is going by 2's. So actually, or it's not, -2, -3, 4, 5, 6, 7, 8, and -9. So my vertex is 6, -9. 6 is going to represent my x, -9 is going to represent my f of x. So -9 equals a times 6 minus 3 times 6 minus 9. 6 minus 3 is 3, 6 minus 9, -3, 3 times -3, -9a, divide by a -9, and the a is also a 1 again. So again, you can either write your answer as 1 times x minus 3 times x minus 9, or you can just write it without the 1, because it's known that it's there. And that would be your either one of those two answers. And our last example, example 6. Malcolm has 80 feet of fencing to enclose a rectangular area for his garden plot. So 80 feet of fencing, so the whole entire rectangle has a total of 80 feet. So that's whole entire perimeter. So part A, write a function for the area of the garden in terms of the width. So first, so in terms of the width, So perimeter formula, you have 2 width and you have 2 length, so 2L plus 2W equals P. So in terms of the width, so we're trying to write an equation for the length. So you're trying to get length by itself. This goes now back to topic 1. Getting L by itself, we put 80 for the perimeter, total of 80 feet of fencing. So subtract 2W to the other side. These are not alike. We cannot subtract them together. Divide everything by 2. 80 divided by 2 is 40. 2W divided by 2 is just 1W, or just W. Now, area is length times width. I don't know my area, so A of W, because that's the variable that I'm going to have on the other side of the equation. So length, I now know that my length is 40 minus W. So that goes inside parentheses times my width. So A of W equals W. I like having my W on the left side as well, times 40 minus W. And then let me see something really quick. Okay, so how did they come up with these questions, with these answers? So A of W equals W. So if I want to find my zeros, I would do W equals 0. That's already one answer. And 40 minus W equals to 0. I would subtract by 40, bring down the negative that's in front of that W, get rid of it, multiply both sides by -1 or divide both sides by -1, and my width is a positive 40. So that's why my zeros are 0, 0, and 40, 0. So that's where the parabola is. So graph the function for the area and determine any constraints on the domain. So my domain has to be 0 to 40. So the function is written in factored form. So the x-intercepts are W equals 0 and W equals 40. So now to draw the parabola, the vertex is midway between 0 and 40. So 0 plus 40, divide that by 2. 40 divided by 2 is 20. So the axis of symmetry is 20. And if I were to plug that back in, (20 times 40 minus 20, 20 times 20 is 400. So the vertex is Y is at 20, 400. So the vertex is located at 2400. So the garden plot needs to have a width greater than 0. However, a width of 40 would use all of the fencing for the 2 sides, leaving no fencing for the other 2 sides. So that's why a reasonable domain has to be greater than 0, but less than 40, not equal to 40. So reasonable domain, 0 is less than W, which is less than 40. And then the range should go from 0 to 400. And again, 0 is less than A of W, which is less than 400. So what dimensions would give Malcolm the greatest area? So his greatest area would be that 400. Because a parabola is opening downward, the y value of the vertex is the maximum value of the function. The greatest area rectangular plot Malcolm can enclose is 80 feet of fencing, which is 400 square feet, which corresponds to a width of 20. So 40 minus the W is 20, And then so that means the length is also 20. So 20 times 20 is 400 square feet. So the dimensions would be 20 by 20. 20 feet by 20 feet. All right, so we're gonna attempt a try it here. Write the function now in terms of the length. So now it's backwards. So for letter A, again, 2L plus 2W is formula for perimeter. The perimeter is a total of 144. They want it in terms of the length. So that means we got to solve for the width. Minus 2L, minus 2L. 2W equals 144 minus 2L. Divide everything by 2. Width equals 72 minus L. So write the function for the area. So area equals length times width. So A of L now equals L times my width is now 72 minus L. So if I want to find my zeros, L equals to 0. 72 minus L equals to 0. Subtract 72. Negative L equals a negative 72. Divide. So this will touch my x-axis at 0 and at 72. So my domain would be 0 is less than L, which is less than 72. They're not asking us to graph it. Okay. So now, if I do want to find my vertex, remember axis of symmetry is halfway. So 0 plus 72, divide that by 2. 72 divided by 2 is 36. And then if I plug that in, 36 times 72 minus 36, 36 times 36 is 1,296. So my smallest range is 0. And my biggest range is 1,296. So this would be my answer here for letter A. Write the function in the area. A of L equals L times 72 minus L. And what dimensions would give Malcolm the greatest area? Well, I know be 36 by 36. So my domain is 36. So if I do 36, (72 minus 36, 36 times 36, 1,296. So the dimensions would be 36 by 36. So, concept summary. The zero product property states that for all real numbers A and B, if A times B equals 0, then either A equals to 0 or B equals to 0. You got to make sure that it's always equals to 0. So for this case, you would have to subtract 5 to the negative 3, make it a negative 8. Once it equals to 0, you can go ahead and factor it, make the equations separate, equal to 0, and solve from there. On a graph, it's where it touches, your x-intercepts are negative 4 and 2. So the do you know how? Solve each equation. Don't know if I'm going to have enough room here. So that would be an x minus 10 equals to 0, an x plus 20 equals to 0. This x would equal 10. This x would equal negative 20. 3x plus 4 equals to 0. X minus 4 equals to 0. This x ends up being a negative 4/3. This x equals a positive 4. Number 7, it's already 7 and 8 are written in standard form, and they're the easy ones. What two numbers, when you multiply, can give me a positive 32, and when you add a 18, x plus 2 and an x plus 16 equals to 0. X plus 2 equals to 0, x plus 16 equals to 0, x equals a negative 2, x equals a negative 16. For number 8, what two numbers, when you multiply, can give you a negative 21, and when you add them together, a negative 4, an x minus 7, and an x plus 3. X minus 7 equals to 0. X plus 3 equals to 0, x equals 7, x equals negative 3. For 9 through 12, I'll do 11 and 12 because those have the a's and they're typically a little harder. So first I need to make this in standard form. So it would be 2x squared plus x minus 15 equals to 0. I'm actually going to erase this. So number 11, 2x squared plus x minus 15. Actually, I'm just going to do 11. Do my slip and slide. 2 times negative 15, negative 30. Rewrite it without my a and my brand new c. What two numbers, when I multiply, can give me a negative 30, and when I add a positive 1, an x plus 6 and an x minus 5, slide the 2 back under, that becomes an x plus 3, that becomes a 2x minus 5 equals to 0, x plus 3 equals to 0, 2x minus 5 equals to 0, x equals a negative 3, and x equals a positive 5/2. For number 13, write a quadratic equation in factored form whose solutions correspond to the x-intercepts. So it's going by 2's. So my x here is a negative 1, 6, 7, and x here is a positive 7. And then I can use my vertex, which is 2, 3, comma, negative 16. So I'm just going to go straight and put it into factored form, which is f of x, a times x minus p, and x minus q. So f of x is a negative 16 equals a, what I'm trying to find, 3 plus 1, a negative going in where there's another negative positive, x again, which is 3 plus 7. Oops, sorry, minus 7. That was not a negative number. So negative 16. So 3 plus 1 is 4. 3 minus 7 is negative 4. 4 times negative 4 is a negative 16a. Negative 16 divided by itself is a positive 1. So f of x equals, if you want to put a 1, you can, or x plus 1, and x minus 7 would be your final answer for 13. 14, factor the equation. All right, so I'm going to erase this one and try doing 14 up here. All right, so what two numbers when I multiply can give me a positive 5, and when I add a negative, those are two negative numbers, x minus 5 and an x minus 1 equals to 0. So that is the factored form of that equation. And then it says find the coordinates of the vertex. So now I need to solve them. X minus 5 equals to 0, x minus 1 equals to 0, x equals 5, and x equals 1. Those are my two zeros. The coordinates of the vertex, axis of symmetry first, so 5 plus 1, which is 6, divide that by 2 is 3, so my vertex, 3 comma, and then I'm going to put it back into my equation. 3 squared minus 6 times 3 plus 5, 9 minus 18 is a negative 9, negative 9 plus 5 is a negative 4. And I'm going to attempt my graph over here. So 1, 2, 3, 4, 5, that's 1, 0. Positive 1 is another 0. 1, 2, 3, 4. 1, 2, 3, it's halfway. 3, negative 4 is my vertex. My y-intercept is a positive 5. 1, 2, 3, 4, 5. You don't have to draw your axis, but I like to draw it. My y-intercept is 1, 2, 3 away from my axis, so 1, 2, 3 away. That would also be a positive 5. And, ooh, let's try that again. Much better. And that would be my parabola for 14. Factored form is x minus 5 times x minus 1 equals 0. My vertex are 3, negative 4. My zeros are at 5 and at 1. And that is 8-2, solving by factoring.